Hello, everybody. I'm so happy to be here with you and to share my first year of works during my PhD studies. I have quite a little to show you actually in respect to your works, but yeah, I try to do that. So, my name is Giuseppe Bergamino, and I just started my uh, second year of PhD path under the supervision of Professor Leonardo Gabrielli. And I came from the Università Politecnica delle Marche in Italy, and my department is the Department of Information Engineering. And first of all, I'd like to introduce you to my research group. So we are the A3 Lab research group. We are quite a bit of people. We have a dozen of us, and so uh, our scientific field is electrical engineering, and we works through three main labs. We do have also a semi-anechoic chamber and quite a bit of computational power. We do have a recording studio, and yeah, our research fields are mainly audio based. As you can see here, maybe just the last one is these smart grids and electric vehicles can sound a bit odd to you, but yeah, we mainly work on signals. So if you see signals from different temporal scales, yeah, that's the reason why we also work on smart grids and electric vehicles, but mainly on music processing, speech processing, and audio processing. And my work is heavily focused on accessible musical interfaces. So today I want to talk to you about my projects I made last year, and I have mainly three projects going on. So first one is about making graphical user interface more accessible. The other one is about immersive telemusic therapy, and the third one, the harder one in a way, is on brain-computer interfaces. So let's go. And yeah, uh, historically we used to use computers through visual feedback, so it's quite a normal thing for us, and it's cool. It works well, of course, unless you are visually impaired or blind. Yeah. And fortunately, we do have different kinds of technologies in order to mitigate this accessibility problem, let's say. And one of them is a screen reader. I don't know if you are familiar with that, but basically you have a speech engine embedded in your operating system, and then your operating system is able to read the elements on your screen. So yeah, that's the reason why it named screen reader, and it basically can read the elements aloud to you. So you don't need to actually see the screen in order to understand what's going on. But the problem is that you have a very slow navigation and you need to memorize your interface. So it's a very high cognitive, you do have a very high cognitive load. So my idea was to try to enhance in a way a screen reader, and the idea is that you have basically a 2D layout on a screen, but I then the idea was to wrap it on a sphere on the surface of a sphere with 3D audio, basically in binaural, and then so I'm using auditory augmented reality, but the other idea was to try to use a head tracker. So the main goal is that, okay, I do have specialized elements, but I can explore the interface with my head. So I can move my head and I can play on proprioception, so on embodiment in a way. and can I can I lower my cognitive load in memorizing the interface with my system? And the answer is more or less yes, because we designed a between group study with 32 participants, and of course we are highly biased here because we just invited Psych 10 participants and they were not able to see the screen, but yeah, we were aware of that. Anyway, the experimental group, so with the specialized element, made 34% fewer reconstruction errors, and I was quite happy with that. And future plans will uh, involve actually expert screen readers, but I'm quite proud of that because I we already start transferring our findings into the industry, and I'm working a lot with the Viscount SPA. Viscount SPA is a company based here in the Marche region, and they basically build keyboards with different kinds of physical modeling, or they do make a lot organs and this kind of stuff. So they do make hardware, but they also have graphical interfaces in order to control them. So I just transferring these design strategies, and like I'm defining a framework, a design framework, in order to translate what I found into an actual GUI, so a graphical user interface. And that's, yeah, that's what I'm working on right now. But we also working on immersive telemusic therapy, so a lot of things are going on. And the idea is that we have two rooms, room A and room B. Maybe these two rooms are in the same facility, maybe in the same hospital, or maybe not. And me with my colleagues Leonardo and Michael, we worked a lot on the network design. So you can see this arrow down here, and one of the main, I mean, in from an engineering perspective, one of the main challenge is latency and how reliable and sustainable the network is. So yeah, we worked a lot on the network side, let's say, but room A and room B are linked through this network, and they also have 3D audio, and they also have video with the yeah binaural microphone and this kind of stuff. The idea was to, okay, we define this system. Does it work or not? And yeah, the interesting thing is that I agree with you. It's quite a challenge to find music therapists interested in these more technological things. And so we have this huge research group made of engineers and doctors, basically clinicians. We lack music therapists, so we kind of improvised a bit. But here the idea was, okay, we do have latency because we have that, but can we play with latency? So can we make the latency information in terms of 100 milliseconds or 50 milliseconds usable for a musician or maybe a therapist? Because what does it mean for a therapist, 50 milliseconds? Basically, not that much. Maybe he or she can even think, okay, 50 milliseconds of latency is good. So we try to link this latency information to a more musical, meaningful information in terms of BPMs. We yeah we test it. Yeah, it kind of works. I mean, we got lots of data to work on, but yeah, it's a long way to go. And the idea is that we need to, first of all, we need to involve music therapists, but also we need to try different kind of exercises, because right now we just tested with the rhythmic exercises taken from an established music therapy protocol, the IMTAP. I don't know if you are familiar with it, but yeah. And now I want to talk to you to my official PhD theme, and yeah, brain-computer interfaces. Yeah, I don't know if you're familiar with this term or not, but the main idea is that you can obtain data from your brainwaves with different kind of technologies, and then you can process those data, extract some features, classify it, I don't know, and then use them to control any kind of device. In my case, the goal is to use EEG sensors. So you have these electrodes, metal electrodes on your scalp, and to use them, and the idea is to control musical interface, musical devices, so like a musical interface, with the goal to make it portable. So we don't want to use such like a huge lab caps with, I don't know, 64 channel and with gel and yeah, with all kinds of problems related to that. But we want to stay portable, we want to stay wearable and usable in a way. And it's not so simple, but we are working on that. And specifically, the idea is to use quite yeah, an established paradigm in the BCI world, which is motor imagery. And the idea is very appealing and very interesting, and we do know from neuroscience that that imaging a movement or performing it activates this more or less the same brain areas. So I can think on moving my right hand or my left hand, or I can move it actually, and the system can detect it, extract a feature I want to, and then map it into the sound domain in a way. It's not so easy. I'm working a lot on that, but we will see. Maybe I hope next year in our next meeting I can give you some actual tests about that.
Giuseppe, just 5 minutes, three
Yeah,
minutes.
yeah. I finished it, and yeah. So lots went on. We will work a lot on GUIs, of course, on telemusic therapy. We have ongoing clinical tests with the Medical Research Center. And yeah, I'm working hard on brain-computer interfaces. Maybe I can, yeah, if you're interested in, we can have a chat later. And if you want to, I'm also here like to sponsor my lab in a way, because we are actively seeking partners for European projects. Basically, we need money to do all we want to do. And yeah, so if you are also interested in this kind of thing, just let us know. And yeah, this is the list of my works. They should be all in open access. And yeah, thank you for your attention, and I'll take your questions or comments if you want to. Thank you.
Thank you, Giuseppe.